Now, hopefully that picture is something that you understand, you've seen before. This is the planet Earth. This is where we all live. You can see the blue of the oceans and the white of the clouds. And some of you might recognize the shape there of Africa. And this is where everybody lives. All 7 billion of the people, everybody lives on this planet. This little blue marble is where we all live. Well, I say little, it's not really very little. I'm sure some of you, it's been a bit of a strange year this year, but some of you have been on holidays and you've gone on jet planes to go on your holidays. If you wanted to fly all the way around this little blue marble, it would probably take you 2 or 3 days in a jet plane, which is pretty fast. So the Earth is quite a big place and it's where we all live. But today I think we want to talk about where else might we live. Now this picture is what we call the solar system. And if on a sunny day you go outside, up in the sky, there's this bright thing where all the hot stuff's coming from. You shouldn't look directly at it because it could hurt your eyes. But it is, of course, the sun. And the sun is in the middle of the solar system. And around the sun are all these marbles, one of which is the Earth. But today we're going to talk about some of the other marbles, and we call them planets. And the thing about a planet is it goes around the sun in a circle, and the Earth goes around the sun in a circle. It takes a while to do it. In fact, it takes a year to do it. That's what a year is. It's how long it takes the Earth to go all the way around the sun. And the ones closer in go around the sun faster, and the ones further out are a bit slower. For example, out here, Neptune, this blue planet, to go all the way around the sun, Neptune takes 165 years to go all the way around the sun. So, where could we live in this place? Well, should we start in the middle then, with the sun? Now, there's a picture of the sun. Well, it looks like a big ball of fire. And that's because really it is a big ball of fire. But it is big. Oh, do I mean big? If this big ball, if we kind of unzipped it and we tried to drop in the planet Earth, it would fit in quite easily. In fact, we could drop more than one Earth in it. 10, 100, 1,000. You could drop 1,000,000 Earths and they would fit inside the sun. The sun is huge. And it is hot. It's hot when you stand outside on a sunny day, isn't it? And it's a good job because it gives us all our energy. If there wasn't a sun, there'd be nothing to make the plants grow. And if the plants didn't grow, there'd be nothing for the animals to eat, including us. So all the life on Earth gets its energy from the sun, and the sun is really, really important to us. But is it a good place to live? Well, it's a big ball of fire, and I think probably that doesn't make it a great place to live. If you were to take your car and put it on the sun, it wouldn't just be hot like a hot day. It wouldn't even melt. It would boil like the water in a kettle. The sun is so hot, it would make steel and iron just bubble away. So I think we can all safely say we're not going to go and live on the sun. So the next place we might live is the marble, the planet that goes around the sun nearest to the sun. And this one is called Mercury. Now, Mercury is small, and as you can see, it's a grey, rocky place. Trouble with Mercury is, well, there's nothing to breathe. On the Earth, we've got air, we call it an atmosphere, and we need that to breathe, but there's nothing at all like that on Mercury. And the other thing is, it's pretty close to the sun, and the sun's pretty hot. So the daytime on Mercury is hotter than an oven. And at night, strangely enough, at night on Mercury, it's colder than the Antarctic. Even the penguins would freeze. So I think we'd have to say we're not living on the sun and we're not living on Mercury either. Now, the next planet out, the next marble that goes around the sun is this one. And this one is called Venus. Venus looks like it might be a better place to live. You can see it's got an atmosphere. There's something to breathe. You can see the clouds in it. It's not too close to the sun. It's, you know, we're getting much further away now, so it's not like Mercury. And it's also about the same size as Earth. So until quite recently, really until I was about your age, people thought under those clouds there might be alien forests and jungles with Venusians living there, and wouldn't that be interesting to see? So they started to build spaceships to go and see, to go and land and to see if there were Venusians who lived there, and maybe we could live there too. Oh dear. Unfortunately, this is what it looks like on Venus. As you can see, it's just hot rock. Look at the sky here. There is an atmosphere, but it's nothing we can breathe. It's very, very hot, and you really wouldn't want to be there. Now, we did manage to land on it. You can see here at the bottom, the metal. This is a spaceship that the Russians landed on Venus. And they knew it was going to be hot, so they made it a special spaceship all ready to withstand the hottest heat they could imagine. And it lasted about an hour before it melted. So, Venus, very, very hot, melts spaceships. Do you know, I'm afraid I don't think we're going to be living on Venus either. Well, the next one out, the next planet out, is a bit more familiar. This is where we started, isn't it? This is our own Earth. And it's a good place to live, because Earth has an atmosphere, and it has the two things that we really need to live. Number one, there's this thing we breathe called oxygen. You need oxygen, and there's plenty of it here. And the other thing is, you can see the blue there, liquid water. Not ice, not steam, but liquid water. And the Earth is the only place we know that's got that. It's absolutely the only place we know there's life. So we'd better do a better job at looking after it, I think, because it's a very, very special place. But if you look up here next to the Earth, you can see another marble, another grey marble. And that one's the moon. Now, the moon's not a planet, because we said planets go around the sun. And the moon doesn't go around the sun. The moon goes around the Earth. So it's a bit different. And we're going to come back to the moon a little bit later on, because I think maybe we'll go and have a look at the next planet out from the Earth. The next planet out from the Earth is this one. And this one is called Mars. They also call it the red planet. And I think you can figure out why they call it the red planet. Now, it's further out from the sun than Earth, so it's colder. But, you know, we don't want to be too hot, do we? And it's also still got an atmosphere, so we're pleased about that too. So just like Venus, people thought, you know, there could be civilizations on Mars. There could be Martians. There might be Martian cities. And wouldn't it be exciting to go and find out? So again, we started building spaceships to go to Mars. And we landed on Mars. Well, it does look nicer than Mercury and Venus. It looks a lot nicer than Mercury and Venus. It does look a bit like a desert. It doesn't look like a great place to go for a walk. And the truth is, although it does have an atmosphere, it's too thin. There's not enough to breathe. And it's still chilly. When Mars gets to its hottest, that's pretty close to the coldest on Earth. But it's much, much better than Venus and Mercury and the Sun, of course. So we've been exploring. And this is how we explore Mars. We've sent over to Mars lots of robots to have a look around. We started a long time ago, about 40 years ago. And there's 2 of these machines going around Mars at the moment, right up there now. And there's another one which you may have heard about because it was called Perseverance. It just launched a couple of weeks ago. And it's on its way to Mars now to have a look around. And this one took a selfie of itself to send back and show us what it was like. And you can see it's a complicated bit of machinery. It's got lots of tools and cameras. It's got drills and hammers. So it can do lots of experiments to work out, what is Mars like? How could we live on Mars? Would it be a good place to... And it's trying to do that because it's trying to answer really there's one very important question. Can you work out what the question is? The question it's trying to answer is the water on Mars. Because like I said about Earth, human beings, well, and all life, we need water and we need oxygen. And the good thing is, if you have some water, you can make oxygen. So if there was water on Mars, that would be brilliant, because that would be a huge way of making it easier for us to live on Mars. And it might look like this. Unfortunately, this isn't a photo of what's happening on Mars, but it might be what happens on Mars. If we can find water on Mars, we're going to need spacesuits still, but people could live on Mars. And you can see here, they're wearing their spacesuits in the thin Martian atmosphere, and their homes don't look like our homes, and they're going to still need rockets to come and go from Earth, but we could probably live on Mars if we could find water there. And I think, I'm not sure if I'm going to Mars, but I think I'd like to see boots on Mars. And I hope it might be your boots on Mars. Maybe you'll be some of the first people to go to Mars and to make this not a painting, but a real picture. So if Mars might be somewhere to live in space, but we've not been there yet, what are we doing then? How are we going to get to Mars? What are we doing about that? Well, we are doing stuff at the moment. I don't know if you know what this is. This is the International Space Station. Right now, 250 miles above our heads is the International Space Station. And on it, there are 6 astronauts right now. Now, if you look at these big thin things here, these are solar panels. You sometimes see them on houses on Earth, and they make the electricity for the space station. The astronauts live in this bit in the middle. It's a funny shape, but the space in there, you might think of it like a double-decker bus. That's kind of the space you've got. And you stay there for about 6 months. Imagine that. Do you maybe have brothers or sisters? Would you like to be locked in a double-decker bus with your brothers and sisters for 6 months? Nowhere else to go? It's not necessarily an easy life being an astronaut. But what they're doing on this space station is really important, because they're trying to work out, how do we live and survive in space? So if we're going to Mars or anywhere else, we're really going to need to learn. And the experiments they're doing about how to stay safe, what it does to the human body, how do you grow food, these are all really important things. But one thing that's interesting is when you're up 250 miles above the Earth, it's not that there's no gravity, but gravity doesn't work the same way. We call it being weightless. And that means that sometimes being an astronaut might be quite good fun. Can you see how they're just floating around? He's trying to swim in the air. I just think this looks brilliant. I would love to go to the space station, have a game of football, float around. My hair might look better. And look at the water. And this is Tim Peake, the British astronaut who was up there just a couple of years ago. Look at the water. So living on the space station in weightlessness is very, very important to work out. And that's what they're doing up on the space station now, which is really, really a good thing. But earlier on, we said there was this grey marble, which wasn't a planet because it didn't go around the sun, it goes around the Earth. It was called the moon. And the moon is a lot closer than the planets to us. And about 50 years ago, the Americans spent about 10 years working out how to land on the moon and come back again. And that was a really big problem and a really difficult thing to get right, because to get there, you need a rocket. You need a very big rocket. And this black and white rocket you can see here was the moon rocket they went to the moon with. And to give it some scale, if you've ever been to London and seen Big Ben, it's taller than that. If you've ever been to Disneyland, it's taller than the Disney Castle. It's even taller than the Statue of Liberty. It's a huge rocket they needed to build, and that takes time. I don't want you to worry about all the words on this, but the rocket is so big. If you see my red dot up here, this little tiny space here, this is where the 3 astronauts sat. And here, this little funny shaped thing, it went and landed on the moon. And we'll see that in a little while. All the rest of it is fuel. There's the same amount of fuel on a moon rocket as there might be in, say, 60,000 cars. So you need to build rockets. And rockets that are filled with fuel, the engine's light, and then they take off. Oh, well, sometimes building rockets is quite difficult. And if you've got an awful lot of fuel, you could get a really big explosion. And this is why space is difficult. You need to do a lot of science and a lot of engineering. Now, don't worry, that was a test. There were no people, no astronauts on that, but it just shows that getting to space is a difficult thing. But they built that big moon rocket, and when that launches, it's not an explosion, but it feels a bit like it. I want you to imagine what it would be like being close to this when it takes off. It's on its way to the moon, and you can see how it's shaking all the equipment. There were actually no people near it. They made the people stand more than 3 miles away. It made such a noise. And so off they went to the moon in their moon rocket. And it took them about 3 days to get there, but get there they did. And this is a picture of a man called John Young. And John Young is on the moon, and you can see in the background here, here's that funny thing that I pointed out that was in the top part of the rocket, and that's landed on the moon. And here you can see his feet. There's a gap between his feet and the shadows because he's jumping in the air because there's less gravity on the moon. So the Americans got to the moon, and in fact, they got to the moon 6 times. And they did lots of experiments to see what the moon was made of. And do you know what they found? It's not made of cheese after all, but never mind. They went there 6 times, they got pretty good at it. And they got so good at it, you can see here, they took a car and they went for drives on the moon. This is the most expensive car that's ever been made.
Bouncing is when he gets his roots to tail. He makes sharp turns. Yeah, that was a good stop. Those wheels just fly. Mark off. Okay.
So I would like to have a go at that car. I think that would be truly wonderful too. So the Americans went to the moon, but I say that was quite a long time ago. So what are we doing in the interval? What are we doing in the middle? What are we doing now? And the answer is we stopped going to the moon because you saw that huge rocket. They used it once. It gets thrown away. And that's a really big problem. Imagine if every time you were going out, you had to buy a new car. You wouldn't be going out very often, would you? And this has been one of the big problems with us exploring space, is that these rockets, you can only use them once. But since we landed on the moon, we're getting better at it now. And just back in May, we launched a new kind of rocket.
5, 4, 3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX, Godspeed, Bob and Doug.
And that was taking, you heard the lady say Bob and Doug, up to the International Space Station. And you might say, but that just looks like any old rocket launch. It's not really very different. But the difference is that the big fuel tanks, they don't just fall into the sea and break up and burn up. Now they come back and they land, so we can use them again. And they've got so good at doing this now that they'll land 2 at once. So this makes going into space much, much cheaper. But of course, that's just all of the stuff that holds the fuel. Here you can see again the tiny little spacecraft coming down. It was up in the International Space Station, and it's come hurtling down through the atmosphere. and it's not going to land on its tail with rockets, it's got parachutes.
Splashdown.
As you can see on your screen, we have visual confirmation for splashdown.
Look at those huge parachutes that they use, and you can see the boat heading out to pick up the astronauts and check they're all right. But again, they can take that spaceship out of the sea and use it again. So this is how we're going to be going back into space and saving lots of money. And hopefully that will take us on back to the moon. There's a big project now called Artemis to take us back to the moon. And we hope we're going to go back to the moon in the next few years. And it won't be just to collect a few rocks and drive a car and then come home again. It'll be to go to the moon to stay. So you can see here all the things they're thinking about building so we can go to the moon to stay. And when we've learned how to stay on the moon, then we're going to go on to Mars. And that is really going to be really exciting. So I think I've probably talked enough, because we've just made a start talking about space and where we might live in it. We started with the sun and hot Mercury and horrible Venus, lovely Earth, and perhaps we'll go to Mars. But we haven't talked about these big marbles out here, Jupiter and Saturn with its rings, and there are some very interesting moons in Saturn and Jupiter we might be able to live on. And of course, that's one star. We haven't talked about the galaxies of millions of stars. We haven't talked about comets and asteroids, and we haven't talked about the black holes. But that might be another day. I think I've talked enough now. Maybe you've got some questions.